Welcome to the CircuitPython Show. I'm your host, Paul Cutler. Today I'm joined by Les Pounder. Les is an associate editor at Tom's Hardware. He's a creative technologist and for 7 years has created projects to educate and inspire minds both young and old. He has also worked with the Raspberry Pi Foundation to write and deliver their teacher training program, PiCademy. Les, welcome to the show.
Thanks for having me, Paul.
Excited to have you on. You wrote 2 articles very recently that I'd love to talk to you about, both focused on the best boards of 2022 for CircuitPython, or RP2040, I should say, and then some of the best add-ons for the Pico itself. What were some of the surprises that you came across as you were testing all this hardware?
How versatile the RP2040 is. I mean, we started off with the Pico, the $4 board, all the way back January 21st, 2021, I think it was. And it just came out of nowhere. It was Raspberry Pi's first microcontroller board. And we just didn't know what was going on with the thing. What does it do? How do I use it? And then the community just sort of grabbed it, and we now see this plethora of boards. They're everywhere, all different shapes and sizes and different configurations, but all based on this one simple microcontroller, which, as we all know, is CircuitPython compatible, which is fantastic. So it means we've now got really good hardware and really good software merged together to create some really great projects.
So I think the Pico came in number 1, which is no surprise based on how little it costs. Was there another board that kind of jumped out at you that you didn't expect to make the list?
Good one, that. So for me, I like Pimoroni's range of boards. They have some really clever hardware considerations that they take into account. So like the tiny 2040, so the first small Raspberry Pi Pico compatible board. And it really was tiny. I mean, I've got one in front of me right now, and it's like a third of the size. Okay, you don't get all the GPIO pins, but what you do get is a curated list of GPIO pins that you can do all the basics, so I2C, SPI, that sort of thing, and standard GPIO stuff. It's smaller, it's a little bit more expensive, but you're paying for the privilege of the smaller package. So You can stick it into projects. And I've seen people build robots with it. So we had a story on Tom's Hardware about 3 or 4 months ago. Someone had built a robot just with a tiny 2040 and a couple of motors which were glued to the bottom of the board. There's no motor control board or anything like that.
Oh, no kidding.
It's just bare run it from the GPIO, which everyone now is screaming, no, use a motor controller. But it was just a bit of fun and it was cheap. Fantastic little project and a great little board.
What do you think it was about the RP2040 last year that led to so much success? Was it because it came from the Raspberry Pi Foundation? Was it just about being available and in stock compared to all the other supply chain woes? What's the secret sauce to that chip?
I think it's a bit of both. It was something new. So Raspberry Pi's got a massive following. I mean, they've sold something like 42 million Raspberry Pis since they started in 2012. So it's 10th anniversary this year. In fact, in about 2 weeks' time.
That's amazing.
They sold all them boards, and they're exceedingly popular, especially in the UK. So that's where I'm based, in case anyone's wondering. So Raspberry Pi's got this following, but also the chip shortage has sort of fueled the search for alternatives. So STM32 chips at the minute are like unobtainium. You just cannot find them anywhere. So, and it's even hit Raspberry Pi Foundation, Raspberry Pi Trading, I should say. So when they were doing their build hat for the Lego compatible projects that they were doing, so it's like an add-on board for a Pi that has a microcontroller that intercepts communication from the Pi to the Lego components. They built it with an STM32, which is what Lego uses in their original kit. The problem is, you can't find them anywhere. Even Raspberry Pi couldn't get any. So they pivoted and went to an RP2040 chip inside the build hat. So they're dog fooding. They're eating their own dog food. And it works. It's a great little board. And really should have pulled that out as well to show everyone. But RP2040 is just getting everywhere. It's even in first-party Raspberry Pi accessories. And now it's in things such as, I'm holding up to the camera now, Pico system. So an RP2040-based games console from Pimoroni that works with CircuitPython.
That's amazing. And for those of you listening at home, I'll make sure to include those in the show notes so you can also see some of the photos that Les is sharing with us. Going back to the Raspberry Pi Pico and the article that you wrote on some of the best add-ons, what were some of your favorite things that you saw there?
Right, my favorite. So all of them I like, but my favorite is just something that is sheer simplicity, and it's the Red Robotics Pico to Pi. And this is so simple, but it's so expandable. So what it is, and I'm going to have it to the camera now so we can see it while we're talking in the show notes as well. It's a Pico which has been soldered to a PCB, and then the header pins at the top of the board are Raspberry Pi hat compatible. So I can get a hat such as Explorer hat, Pibrella, whatever I fancy, put it on there, and as long as I know how to interface with that board, so I2C, SPI, pins, whatever, I can
Right.
use old hats with the Pico. This is really cheap. I think it's like under $10 with the Pico soldered on for you. And it just opens up a whole
Wow.
world of messing around and playing. And it's all right, it's not the most technically, impressive board. It's just pins that have tracks that connect pins together. But it's so accessible for just reusing all that old kit that I know I've got loads of. And probably the people listening to this now are saying, yeah, I've got a load of Raspberry Pi hats somewhere.
So you shared a photo of me of all the different boards you have. So we've talked a little bit about the RP2040, and I'll make sure we get that photo in the show notes because it's impressive. Um, what are some of the differences between some of the chipsets compared to the RP2040 that we've talked a lot about? So you've got the STM that you referred to.
Hmm.
There's the ESP series from
Yeah.
Espressif. Help our listeners at home understand, what are these different chipsets?
Well, all the different chipsets, all the different system on chips, the SOCs, as they're sometimes called, they're all the different ways of having RAM, storage, processor power, and then such things as Wi-Fi or Bluetooth connectivity, all in a set package. So ESP, so Espressif, they have the ESP8266, the ESP32, which are well known for their Wi-Fi connectivity. In fact, two more of these boards arrived today in the post for me to have a play with.
The 8266 is really popular in the IoT world with people doing projects with things like Home Assistant. Is that correct?
Yeah, it's so cheap. ESP8266 has been around for years, a hell of a long time now, and it's found its way into all sorts of projects. You can buy products in the store with an ESP8266. I bought a light controller, an RGB light controller, a few years ago from the store. I took it apart because that's what I do. And I looked inside, and there it was, an ESP8266. And the debug pins and the control pins were all there ready to go, so I could hack it if I wanted to. And yes, I have done that. But it's a really nice little chip because you can also get these breakout boards. You can get ones that are designed for a breadboard, or you can get ones called the Wemos D1 Mini, which are this unusual form factor. It looks like a tiny Arduino, but they are great fun to just hack around with because, again, they're cheap. Even in the current climate where it's expensive to find chips, you can usually find them for about $4 to $8, depending where you shop. And you can flash on MicroPython, CircuitPython, and have a good bit of fun with these Wi-Fi enabled chips.
So if for someone just starting out with CircuitPython, what board or boards would you recommend to them? What are the top couple to take a look at?
For me, it's the Cytron range. So this isn't biased. I've paid my own money for most of these boards, and fantastic little boards. If you think of just a standard microcontroller board, you've got your USB interface, you've got your pin connections. There you go. That's your dev environment to mess around with. With Cytron stuff, they put on a few extras here and there. So if I just go to the camera now for the video feed, you can see center of the screen. I've got a purple board. It's about 4 inches wide and about 2 inches tall. It's got a Pico in the center of it. So this board, the Maker Pi Pico, is $9, and we've got all the GPIO pins broken out in rows, either side, or columns, I should say. I've got LEDs on those pins as well, so I can see if the pins are active without connecting anything to it. So in a classroom environment or in the home, where if you're not comfortable with electronics just yet, this shows you what's going on. It shows you that a pin's turning on and off to flash an LED. We've got Grove connections. These things on the left and right, there's like a white polarized connection. They've got 3 to 4 pins inside them generally. These work with Grove components to make electronics a little bit simpler. So you can buy like sensors, or PIR sensor, passive infrared, the same thing that's used in alarm systems, or you can buy motors, buzzers. LEDs, all that sort of thing. Plug them straight in without having to worry about which pin goes where. And initially, the MakerPi Pico and the other ones as well, there's another one to the left here, the RP2040 version, and the new Maker Nano RP2040. They were all designed to work with MicroPython, and they do. But they found their home with CircuitPython because of the ease of use of these boards and the ease of use with CircuitPython. If I want to do something with, say, the micro SD card on the MakerPi Pico, I just download the appropriate library from CircuitPython, put it in the libs folder, and away we go. Easy to do.
That's amazing. Is
It
that the
is.
same board that you just wrote an article about in the last couple of weeks?
The little one here, yes, that one there, that's about 6 days, 7 days old, that article. And fantastic little board. So normally boards of this size, when you put them on a breadboard, you're very cramped for space either side of the board. You may have one column of pins and that's it. With this one, you've got 2 to 3 because cleverly, they've got right angled pins on the underside of the board, which means, if I hold it up to camera there so you can see, it's slightly narrower by about one row either side. And that gives us just a little bit more space. But also, cleverly, we've got maker ports. Let's get this in shot. There we go. And these are Stemma QT compatible connections. So Stemma QT, we should be aware of from Adafruit's range of boards, but if not, it's I squared C broken out into a proprietary connection. It's like a polarized connection, just same as Grove, but very small. And there's even a
And
Grove
what
converter for this board as well, so you can use Grove components and Stemma at the same time.
and what are some of the examples of what you might connect via Stemma or Grove? What are the kinds of sensors that people might want to use with it?
Oh, lots. Oh, there's so many. So the first one you'll think of is sensor, temperature. Usually temperature, light, sound, the ones that we go to, because that's what we experience in our common lives. We see light, we hear sounds, that sort of thing, and we experience temperature. So we want to log that and use that in experiments. But you've also got RFID readers, NFC, PIR sensors. You've got rotary encoders, you've got potentiometers, all of these things that will return a value when they're interfaced or interactive with. And with Stemma QT and Grove and Quick and Quest, which is Pimoroni's sort of version of Stemma QT and Quick from SparkFun, you can just plug straight in and away you go. You haven't got to worry. And it's really easy to do and great fun. So kids can get involved with electronics with CircuitPython. And also, if you're just starting out in electronics, it's a good way to sort of find your feet before you want to go into the big projects.
Hi, it's Paul. I'll get you back to the show in just a moment. Thanks for listening, and if you like what you're hearing, hit the subscribe button and leave a comment that you subscribed. For other ways to support the show, visit circuitpythonshow.com/support. Now, back to the show. So I understand you just built yourself a CircuitPython project that you shared on Twitter. Elgato announced their new Stream Deck foot pedals, and you thought to yourself, I can do that and do it cheaper.
Yeah, oh yeah. I thought I can do it cheaper, and being a maker, I thought, yeah, I just want to make it anyway. So you're going to hear some old man sounds now when I just go down and pick this thing up because it weighs a ton.
Thank you.
Here we go. So I have in my hand right now a aluminium box, or aluminum for the American viewers, and it's got some guitar stomp switches on it. This is all heavy duty. It's meant to be interfaced with your feet, so really heavy use. And inside here was the KB2040, the keyboard from Adafruit, with CircuitPython, and it was emulating a USB keyboard. And all I did was have Shift A, Shift B, Shift C on these foot switches. So when I pressed it, it would change from one scene to another. So right now, how I'm controlling my OBS feed for the show is here we go. Let's get that in shot. And that's another CircuitPython device.
Is that the keybow?
Yep. It is the Venus Dust, the Kibo 2040. It's actually an old one now because the new ones have got Stemma QT on them. Mine hasn't, unfortunately. So I can control my video feed now, and I can go from one scene to another just by pressing keys on here.
And I'll make sure to include photos of those, but that looks almost identical to what a guitarist would use on stage.
Yeah. That's what. So in my youth, my many years ago now, I used to play guitar, not in a band or anything like that, just my own personal pleasure. and I had stomp pedals, so I knew what parts to get. And I thought, yeah, I can make my own, and yes, I did. I got something wrong though, and I'm going to highlight a failure because I love to highlight failures because fail is our first attempt in learning, and that's something that a friend of mine, Carrie Ann Philbin, taught me years ago. This is a failure because I should have had this line of switches in a triangle because I've got size 10 feet in the UK size, which means when I put my foot on here, I can get both of them at the same time.
Oh, sure.
If I'd have done it in a triangle on the corners, so middle and then bottom left, bottom right, I'd have had a lot more space to do it. So that was a failure. But it's nothing that a drill and a bit of time can't fix.
Well, that's the beauty of being a maker, right? We learn from our mistakes and we do it all over again.
Yep, we do it all over again and normally make more mistakes and then learn from those mistakes and do it all over again.
So the other thing that you've been really into lately is retro tech and going back to the computers of at least my youth, since I'm getting up there in age, and taking a look at the things like the Sinclairs and Commodore 64s. Tell me a little bit about your experience working with those lately.
Oh, well, for the last just short of 2 years, I've been working with Linux Format. So, Linux Format is a magazine in the UK and America as well, which focuses on the Linux scene. And I've been working with them for at least 11 years now. And the last 2 years, I've been working on retro computing articles. So, going back to the roots of computing. So, looking at the Commodore 64s, the Amigas, the Atari STs, even further back, Commodore PET, Apple II, Sinclair computers, and showing how these machines were used in their time to do similar projects to what we do now. Granted, what we have now is a lot more advanced and technical. We've got lots of better kit. But I never knew before doing my articles that the Commodore 64 had a user port that could be used to do electronics.
I had no idea.
I was flabbergasted when I found it. So how does this work? So I went to Tindy and I got a board to break out the connections, got a pin out, worked out what things went where, and then learnt how to interface with those pins by using a series of pokes and peeks. So poking something into a memory register and then peeking to see what's changed. So it's a bit different to Python. We just say, LED on, LED off, that sort of thing. We actually have to know where things are. But it wasn't too difficult. I mean, I did a personal blog post on this as well, just as an aid memoir for myself to remember in years to come. And it's fascinating because BASIC was sort of the language of that time. It was Python, really, for the 80s. It was accessible to everyone. It was simple enough to understand, but it could do some quite advanced things if you were prepared to put a bit of time in. And okay, sure, it couldn't throw around microcontrollers and motors and that sort of thing as easy as what we can now, but you got fantastic results with very little code, maybe 20 lines of code to do something quite complex.
So out of all the computers that you've been going back and taking a look at, is there one that jumps out to you that's still your favorite all these years later?
Completely biased, but Commodore 64. That was so. I was a Commodore kid. I went through the ranks of the Commodore 16, the Commodore 64, then the Amiga range, and it was then that I went off to the dark side of PCs, the 486DX33. But Commodores are just they've got excitement for me. It's the whole playground mentality. So everyone's got Commodores. They're all talking about the games that they've got. But do we talk to the kids who've got Sinclairs? Well, not really. But now we do because it's a big open community of retro gamers. But it's fascinating. All this old tech is becoming new again.
I'll talk to Scott Shawcroft later in the season, and one of the visions that he has for CircuitPython is to take something like the Raspberry Pi 400, which
Mm-hmm.
has the keyboard all built in, all one device, and just plug it into a TV using an HDMI cable, which is almost the exact same experience we had as kids. So it's cool to see all the retro tech coming back, but at the same time, that vision is still being realized all these years later.
Yeah, I mean, in the 80s, you turned on the computer and there you go. The basic interpreter was there, ready to go. And from there, you could type in your own codes to make something, or you could just load your discs or tapes. In the UK, tapes were the main thing. And it just immediate. And what Scott's doing with CircuitPython to make it immediate on bare metal is fantastic. So now, if we get a Raspberry Pi Zero 2W or a Raspberry Pi Zero, put CircuitPython on bare metal, instant on, we can have kids hacking around in Python really quickly, really simply, but backed up by all this fantastic library that has neopixels, motors, sensors all ready to go. So the kids don't have to learn all that just yet. Of course, we want them to learn that. We want them to expand their knowledge. But when you start learning something, you don't want to be inundated with all the technical stuff at once. You want the good stuff. That means you're going to keep learning and keep winning.
So I've been asking you all the questions. Now we come to a segment where I call Turn the Tables. I'm a big vinyl record fan. I've got a turntable here at home. What question can I answer for you?
Well, I'm going to throw one back to you because we've been talking about all the stuff of yesteryear. So vinyl is yesteryear, but it's coming back really popular now. I want to ask you a question of you're trapped on a desert island. You've got all the creature comforts you could desire. So you've got food, water, heat, shelter, everything that will keep you alive. But you can only take one computer and its entire back catalogue of games to entertain you for the rest of your life. Which one and why?
Wow, that is a fantastic question. The first one that jumps into my mind is the Sega Master System, or here in the US, the Sega Genesis. That was, for me, the pinnacle of gaming. And I know I'm dating myself by that. But I have so many memories as a kid, as a teenager, and as a young adult when I first moved out of my house, of my parents' house, and took that with me of playing, American football or, um, you know, Golden Axe. There were so many games. I was a Sega guy. I wasn't a Nintendo guy. So if I could just take one thing, that would
Mm-hmm.
probably be it. I don't need anything modern. I have fun reliving my youth, whether it's with my record collection or some of the retro gaming stuff going on. I've been working on trying to build a stand-up arcade cabinet for literally 20 years, which is kind of embarrassing to admit to. But I love my retro tech, and I've always loved my Genesis. I still have that original Genesis, and every couple of years I take it out, and my wife's eyes just light up. Um, it's so fun to go back to. So if I'm stuck on a desert island, I know there's not hundreds or thousands of games for it. That's probably the one thing I'm taking with me, if it's not a
Excellent.
Kindle full of books. But
No, I'd take a Genesis or something like that. So I had a Genesis. So in the UK, it's a Mega Drive, we called it. And I had one. And for about a year, the only game I had was Altered Beast.
yes,
And I could,
classic.
oh, I do not like that game anymore. It was the only one I could play. So when I got Streets of Rage about a year later, I played that to death. And I mean to death because I hated Altered Beast so much. But then I got a Super Nintendo, a SNES, and Mario, Super R Type, Super Contra, or Pro Protector as it's called in the UK. All those classic games, Legend of Zelda, that blew me away. So the Genesis, unfortunately, got put to one side because it only had the two games, whereas the Super Nintendo had all of these fantastic games that were just coming out that just looked better, and I enjoyed myself immensely. Probably far too much it may have affected my school grades.
Well, I think that goes for all of us, but at the same time, I don't think we'd be where we are today with that without both the retro tech and without the games. I think that inspired entire generations of folks to get to where we are today.
Definitely.
So tell me how you got into CircuitPython specifically.
For me, it took a plane journey. And this is where we start a very interesting story. Well, I hope it's interesting for you. Um, I was invited to PyCon in the US in 2018, along with, well, I shouldn't say along with, I was there to support a young man named Joshua Lowe. Joshua Lowe, you may know, was all about code on Twitter. He created some software called EduBlocks, which is a way to write Python code with blocks in a web browser. Very clever. Take a look if you can. And he was invited to go over to the States to talk about his project. And he did. So I went along because I was his mentor at the time. I was teaching him a bit of Python. So, disclaimer, he now knows far more Python than me. He's a very clever lad. But I went to the Education Summit at the start of PyCon and I met Scott Shawcroft. And having a chat with him, and he says, "Oh yeah, we're giving away some Circuit Python boards." And I'm like, "What Circuit Python?" And he hands me this thing. It's about an inch in diameter, this tiny board, the Gemma M0, specially made for PyCon. And it was my first CircuitPython board, and it was like, oh, right. So he explains about MicroPython, CircuitPython, the link between the two. And I then went into a session with Scott and Katney, and I learned how to do some very basic CircuitPython work with RGB LEDs, so NeoPixels. And it just sort of got me hooked. So when I got back, I ordered a Circuit Playground Express, and then I just went a bit mad, and I've got lots of different boards now. And it just sort of clicked in my brain how CircuitPython works. So I've used MicroPython before. I've got one of the Pi boards, one of Damien George's original boards, and that worked well, and I enjoyed it, and I still use MicroPython. But CircuitPython for me was just like an abstraction which made sense. It took away the complexity for the user, and we've got these cool little boards that can use crocodile clips and all sorts of connections to make some really cool projects. And so I just had fun. And in that session, just making LEDs turn on and off with CircuitPython and learning how it all interacted with everything. And then speaking to Nicholas Tolove, who created the Mu IDE, and he showed me how it works with CircuitPython. It's like blown away because Mu was so simple, CircuitPython was so simple, the hardware was so simple, anyone could do it. So we all got in our swag bags at this PyCon and these $8 Gemma M0 boards to take away and play. And it just started the whole thing for me.
So it seems like NeoPixels and the Circuit Playground Expresses are almost like a gateway for lots of people coming to CircuitPython.
Oh, yeah. Yeah, NeoPixels I have a deep love for. I use them all the time, and I'm not even joking. To my right in front of my television, I've got a Cutie Pie which controls the beauty lights, what you see over a mirror in like a movie studio. And there's NeoPixels inside them, so I swapped out the LEDs. So now it glows around the television in these lovely bright colours. At Christmas, we'll have lights in the window, and we'll have NeoPixel lights. The tree is fully NeoPixeled. Everything's NeoPixel. We've got a star that has WLED, so I can control NeoPixels remotely from my phone anywhere in the world with MQTT and different topics. Fantastic. I love NeoPixels, and when Circuit Playground Express has them on the board ready to go, as do other boards as well, it's like, okay, that's instant brain candy.
Les, thanks so much for being on the show today.
Thanks for having me, Paul. It's been a pleasure.
All right, check out Les's writing at Tom's Hardware and Linux Format. Thank you for listening to the CircuitPython Show, an independent podcast with the people in and around CircuitPython. For show notes, transcripts, and to support the show, visit CircuitPythonShow.com or follow the show on Twitter at CircuitPyShow, that's CircuitPy Show. I'm your host, Paul Cutler, and I'll be back next episode. Don't forget to hit subscribe and stay safe.